Are you ready? My friends, today we're going to teach you some specific topics in statistics and probability. Hello students! For today, we will going to solve problems involving sampling distribution of the sample mean. But first, before we will going to proceed to our objectives for today, we will going to identify first the important keywords of this topic. First is that the central limit theorem. What is a central limit theorem? A central limit theorem states that if you have a population with a mean and standard deviation and take sufficiently large random samples from the population with replacement, then the distribution of the sample means will be approximately normally distributed. Next one, the sample mean. The sample mean is a mean from a group of observation from an estimated population mean. Next one is the sampling distribution. The sampling distribution is a probability of distribution of a statistics obtained from a large number of samples drawn from a specific population. The sampling distribution of a given population is the distribution of frequencies of a range different outcomes that could possibly occur for a specific population. Now, the last one, the sampling distribution of the sample mean. Sampling distribution of a sample mean is a frequency distribution of the mean computed from all possible random samples of a specific size taken from a certain population. The probability distribution of the sample mean is called the sampling distribution of the sample mean.
To formulate our own problems involving sampling distribution of the sample mean. Number 2. To illustrate the steps in solving problems on sampling distribution of the sample mean. Number 3. To illustrate our problem case by sample sampling mean. Number 4. To determine the step-by-step method of solving problems involving sampling distribution of the sample mean. Number 5. To know when we will use these two specific formula.
And now, here are some problems involving sampling distribution of the sample mean. Let's go!
Illustrative example, probable time. The mean time of a group of junior high school students take to finish a quiz in mathematics is 54.8 minutes. The standard deviation is 10 minutes. Assume that the variable is normally distributed. What is the probability that a randomly selected junior high school student will finish the quiz in mathematics in less than 45 minutes? To get the probability, we will first identify the given information. Whereas the population mean is 54.8, the population standard deviation or sigma is 10, and the given is 45. Then, we will identify what is being asked. So, we are asked to find the probability that X, or the selected junior high school students will finish the quiz in mathematics is less than 45 minutes. Step 3 is to identify the formula to be used. And since there is no specific number of randomly selected students, we will assume that the problem is pertaining to a population. Hence, Z equals X minus mu divided by the standard deviation of the population.
Last step is to compute for the probability. Using this formula, we will first do the substitution. So Z equals X minus mu divided by the standard deviation. It will become Z equals 45 minus 54.8 divided by 10. It will give us negative 9.8 over 10. Dividing negative 9.8 by 10 will give us an answer negative 0.98. Then, we are asked to find the probability of X less than 45 by getting the area under normal curve. Using the Z table, we will find the equivalent of negative 0.98. Upon finding out, we will get 0.1635. After this, we will need to sketch the normal distribution curve. We just need to sketch the negative 0.98 below, so we will only shade to the left side. Then, we need to put 0.1635 as the name of the shaded area. Finally, we need to add conclusion. Therefore, the probability that a randomly selected junior high school student will finish the quiz in mathematics in less than 45 minutes is 0.1635 or 16.35%. We can get this percentage by multiplying 0.1635 by 100.
Next question. If 81 randomly selected junior high school students take the quiz in mathematics, what is the probability that means it takes the group to finish the quiz? Will be more than 58 minutes. To get the probability, we will just follow the step of the previous question. The first step is to identify to give information whereas the population mean is 54.8, the population standard deviation or sigma is 10, the sample mean is 58, and the number of randomly selected junior high school students is 81. Then we need to identify what is being asked wherein the P or the probability the sample mean is greater than 58. Step 3 is to identify formula should be used, and since we have 81 randomly selected junior high school students, we will use the second equation of formula.
Therefore, the probability that 81 randomly selected junior high school students will finish the quiz in mathematics in more than 58 minutes is 0.0018 or 0.18%. And to get the percentage, again, multiply 0.0018 by 100.
In the meantime, it takes a group of runners to go to the finish line in 50.6 minutes. The standard deviation is 6 minutes. Assume that the variable is normally distributed. What is the probability that the randomly selected runners will go to the finish line in less than 48 minutes? To get the probability, we will first identify the given information, whereas the population mean is 50.6. The population standard deviation or sigma is 6 and the given is 48. Then we will identify what is being asked. So we are asked to find the probability that X for the selected runners to go to the finish line in less than 48 minutes. Step 3 is to identify the formula to be used, and since there is no specific number of randomly selected runners, we will assume that the problem is pertaining to a population, hence Z equals X minus U divided by the standard deviation of the population. Last step is to compute for probability. Using this formula, we will first do the substitution. So Z equals X minus U divided by the standard deviation, it will become Z equals 48 minus 50.6 divided by 6. It will give us negative 2.6 over 6. Dividing negative 2.6 by 6 will give us an answer 0.42.
Since we are asked to find the probability of x less than 48 by getting the area under normal curve using the z-table, we will find the equivalent of 0.43. Upon finding out, we will get 0.3336. After this, we will need to sketch the normal distribution curve. We just need to sketch the 0.43 below, so we will only shade to the left side. Then, we need to put 0.3336 as the name of the shaded area. Finally, for conclusion, therefore, the probability that a random selected runners to go to finish line is less than 48 minutes is 0.3336 or 33.36%. We can get this percentage by multiplying 0.333 to 100. For the next question, if randomly selected runners to go to the finish line, what is the probability that the mean takes the group of runners to go to the finish line will be less than 48 minutes? The first step is to identify given information, whereas the population that mean is 50.6. The population under deviation or sigma is 6. The sample mean is 48. And the number of randomly selected runners is 49. Then, we need to identify what is being asked, wherein the P or the probability of sample mean is less than 48 with random selected variable of 49. Thank you.
Step 3 is to identify what formula should be used. And since we have 49 randomly selected runners, we will use the second equation or formula. Step 4 is to compute for the probability. J equals x bar minus mu divided by the sigma over square root of n. Upon substitution, we will have 50.6 and minus 48 over 6 over square root of 49. Then we will have negative 2.6 divided by 6 over 7. That will be equal to negative 3.03. Since we are asked to find the probability of x with a randomly selected runner in a less than 48 by getting the area under normal curve, using the z-table, we will find the equivalent of negative 3.03. Upon finding out, we will getting 0.0012. For sketching the graph, we need to put the negative 3.03 on the right side and shade it. Then, we need to put the 0.00.12 as the same name in the shaded area. In conclusion, therefore, the probability of 49 randomly selected runners to go to the finish line in less than 48 minutes is less than 0.0012 or 0.12%. And to get that percentage, again, multiply 0.0012 by 100.
I hope you learned from today's lesson. Goodbye!